Today I want to take my time to explain some of these electric terms. In physics, when you start doing electricity, there are certain terms you will be hearing consistently, like EMF, which is the same as electromotive force, PD, potential difference, then current. So basically, these three terms will be reoccurring in most of questions connecting electric circuit. So let me take my time to explain it. EMF. What is EMF? The EMF, if you watch the diagram here, this is an electric circuit. In this electric circuit, this symbol here is a symbol for a cell. Either you call it a cell or a battery. Cell or battery. So the battery is the source of the energy for that electric circuit. So the EMF talks about the energy of the cell or the what? Battery. And how is it defined? This electromotive force. It is defined as the potential difference between the two terminals of the cell when the cell is not delivering current to the external circuit. So let me put it this way, that EMF is equal to PD between what? Terminals of a cell when the cell is not delivering current to the external circuit. So EMF is the same as PD, but the difference is that EMF is bigger than PD. Another way you can define EMF, you can define electromotive force as the work done in taking a unit charge of 1 coulomb around an electric circuit. Okay, let us go to potential difference. Maybe from there you can understand it better. Potential difference itself is the work done in taking a unit charge of 1 coulomb from one point in an electric circuit to another, like taking a charge from A to B. The work that is done in taking a charge from A to B is known as potential difference. Or the work in taking a charge from B to C is known as what? Potential. So you can use V, you can see V. VBC means work done in taking a charge from B to C. Then, when you look at what is happening in this circuit diagram, discover that these two resistors here, the two resistors in this circuit, they have the same potential difference. So it is the same potential difference across 3 ohms here that is applied for the other 3 ohms. So they have the same potential difference across each of them because it is just 2 points. So the energy required in driving a charge from this point to the other point remains the same irrespective of having a parallel connection. Then we'll talk about current. So how do you define current? The current is rate of flow of charges in a conductor. Rate of flow of charges in a conductor. So you see that it is the same as quantity of charge divided by time. And the unit is what? Ampere. The unit is ampere. So with this now, we can generate or derive a formula for electrical energy. So let us see what an electrical energy is using the basic foundation that we have laid so far. So we can say that electrical energy, we are looking at derivation of formula for electric energy. So what we are going to do is, we'll start with the potential difference. For us to derive a formula for electric energy, we are going to start with potential difference, which is PD. And this PD, we said earlier, is the work that is done in moving a charge from A to B. Work done in moving 1 unit of charge. 1 unit of charge from one point to another. So if it is like that, we can now say it is equal to W over Q. W is work done. Q is quantity of charge. So we can write PD the same thing as V. So V is equals to W over Q. Then we can make work done the subject. Work done is equals to VQ. Then remember that we defined from definition of current, we say that current is equals to Q over T. So if I make Q the subject, I'm going to say that Q is equals to IT. Do you understand? So I can substitute this into this equation. So putting Q equals to IT into the equation of work done. Say electric work done is equals to VIT. VIT. So I call this the first formula for electric energy. So we can recall from Ohm's law. Ohm's law states that V is equals to IR. So this formula, equation 1, can be changed to W, which is work done, is equals to, removing V, replace it with IR. IR bracket IT bracket close. That is going to give us that the work done in an electric circuit, which is equal to the electric energy in the circuit, is equals to I squared, I times I is I squared, R multiplied by T. So you now have this as equation 2. So there are 2 equations for electric energy. Electric energy is given by, the first one is VIT, which can be written as IVT in alphabetical order, and it is also equal to I squared RT. So any of these 2 equations can be used when calculating an electrical. Any of these 2 equations can be used when calculating electrical energy. If this is the first time you are watching my video on Facebook or YouTube, please do well to share the video, like the video, and share with your friends. Share it so that I get to most of the students that are finding physics difficult, because this page will go a long way in assisting them overcome the phobia they have for the subject. Thank you.